So tonight's a bit of revision, and I'll also go ahead and let y'all have the time to work on the quizzes as necessary. So, first things first, what do y'all remember about scientific versus engineering notation? Mhm. All right, so engineering moves in groups of 3. Okay? It moves in powers of 3. Scientific moves in groups of 1. So every time you move it, you count it. Scientific notation, the number in front of the decimal should run between 1 and 9. In engineering, it should be running from 1 to 999. Okay? Any questions on that so far? No? So let's put it into a bit of practice here. Okay? So scientific notation, what should this particular one be? Yes. Scientific. Should be looking at 1.2 times 10 to the 4th. Let's see if that follows our rule for scientific. Is the number in front of the decimal between 1 and 9? Yes, it is. All right. Do I have an exponent? Yes, I do. Now, engineering notation is the one where you should see 12 times 10 to the 3rd. So does 12 fall between 1 and 999? Yes, it does. Second question, does my exponent fall into it's a power of 3? Yes, it does. That is correct. Looking at my metric prefix, what should it be? Should be kilo. Why is it kilo? All right, let's kind of scroll up. I know this is going to be really weird looking right here. But if you look, tera, giga, mega, kilo, milli, micro, nano, pico. That's how this particular one runs. Kilo, 10 to the 3rd, 10 to the 3rd. Does that make sense? Okay. So 10 to the 3rd is kilo. Might have misspelled that. Always misspell kilo. I don't know what it is. I'm just going to leave it as abbreviation. Okay. So that being said, let's look at this one down here at the very bottom. We have 390 million. Okay. It's my scientific notation. 3.9 times 10 to the 8th. Does that fall in my scientific parameters? Is it a number between 1 and 9 in front of that decimal? Yes, it is. That's the biggest one for scientific. What's my engineering notation? Should be 390 times 10 to the what? 10 to the 6. What would that give me for my prefix real quick? It should be mega. So looking back at my engineering notation, does that fall between 1 and 999? Should that fall between 1 and 999? It does. So thus, that is my engineering notation. So I'm only going to do a couple of these per section, guys, because this is your homework, not mine. Y'all need to practice more than I do, believe me. I do this in my sleep sometimes. Not because I want to, but because it is ingrained in my brain. Okay? Anybody got questions about positive powers of 10? What's the biggest thing you need to remember when dealing with this, guys? You need to track how many times you move that decimal, right? Yep. All right. All right. So let's look at negative powers of 10. All right. So let's look at this guy first. Okay. Let's look at that one first. First of all, what would my scientific notation be? Actually, what should be the first thing I do? Something even simpler. Nope. First of all, the best thing to do for any of these with the very nice long bunches of zeros is break them visually. What do I mean by that? I mean, take a big number like that and start breaking it down. Why? Because visually it lets you count them more easily and track it more easily. Okay? So what should my scientific notation be for this one? I'm not sure how to do a -7 on a raised to the -7. So you'll just have to put up with me doing that. But 1 times 10 to the -7. How do I know? Because I moved it 3. I moved it 6. Move it 1 more, and that's 7. Does everybody see what I did and kind of understand what I did? So what would my engineering notation be? 100 times 10 to the negative 9. Makes it a lot easier whenever you add those commas in there, doesn't it? Why? Because you can already see where your groups of 3 are. Does that make sense to everybody? So what should be my metric prefix for this one? It should be nano. If you're looking at the list, it should be nano. Milli, micro, nano, pico. All right. Looking at this one right here, what's the first thing I should do? Need to break it up, right? So I can do this. If I'm doing it with pencil and pen, I can just put a line between. I'm doing it on computer though, so I'm just gonna go ahead and put a comma in there. Why? Because I like commas. Commas make work a lot easier. So what is my scientific notation for this one? 9 times 10 to the negative what? 9 times 10 to the negative 10. All right, what should my engineering notation be for this one, guys? Twelve. Power 3, right? How do I verify this one? I say, well, is the number in front of where my multiplier there, does that fall between 1 and 999? Yes, it is. I'm good for that one. Is my exponent, which I don't know how to really make it do an exponent on this, so it is what it is. So is my exponent a multiple of 12? I'm sorry, multiple of 3. Yes, it is. So that should be my answer. Then the next one is, what is my metric prefix? It is pico. Does everybody understand? Have I lost anybody? Anybody have any questions?
Count the zeros from in front of the 10, in front of the 9, in front of the decimal.
Yes.
So the 12. 12 actually.
Which one are you talking about? This one? All right. So the thing is, this is why I personally don't put zeros in front of my decimals, because that can confuse things. But yes, after that, after the decimal, I count my zeros. So I've got 3, I've got 6, I've got 9. I've got to move another 3 places. Does that make sense? For engineering notation. So I've got 1 where I get behind the 9, and one of those things, and one of the concepts a lot of people have to really kind of understand and get through when it comes to working behind that decimal is the fact that there are zeros that just kind of hang around other numbers. Okay? They're in front of numbers in the positives, and they're behind numbers in the negatives. So all I'm doing is taking those zeros that are technically basically nothing but placeholders. And I'm just pulling them in and using them.
Okay, so it's gonna be 3 zeros for that.
2 zeros.
2 zeros.
Because I've got to move by a power of 3. But I don't want to change the value of the number at the same time. Does that make sense? So I don't want to change the value of the number, but I do need to change this into the proper notation. Okay. So I'm just kind of borrowing the number, the unused zeros that are out there, just like on old calculators. So that's all. Does that make sense? All right. So moving on down here, let's look at this guy right here. That's quite a bunch of numbers. What should be the first thing I do with those? I don't like having all those zeros without having some sort of organization, right? So let's split them off. See, again, I get to use commas. Whenever you're doing this for anything else, it is actually really easy to go ahead and just use, commas, whatever you want to do to visually break it up. And I do recommend to visually break it every time, just because it's less headaches. Okay? I figured out how to do it, and I just always do it because it's less stress and headaches in the end of the day. So what should my scientific notation for this be? I'm not sure. 10 to the 11th. Now, how do I know that? Well, I moved it 3, I moved it 6, and I moved it 9. Now, let me ask before we move on. Have I got one number in front of that decimal yet? No, I don't. Only one number between 1 and 9 for scientific. So I move it forward 2 more places. So that's 10 and 11. I end up with 4.726 times 10 to the 11th. Does that make sense? So when we go to engineering notation, what should it be? Again, I don't know how to make it do the nice little exponential thing, so make it just look like that. So 472.6 times 10 to the 9th. Okay. So what should be my metric prefix here, guys? Should be giga. 472.6 giga. I'm going to just kind of come over here and copy the ohm symbol. Apparently I can't. So that is giga ohms. All right. All right. So any questions about how to do any of these problems right here, guys? The biggest thing with all of this is to track your movements. Okay? Oh no, I'm on the wrong side of this. That would be why. Control C and Control V. So for this one, go ahead and put my commas in. Why? Because it visually breaks it up so that I can put it into notation much easier. So this particular one for scientific should be what? Should be 4.36 times 10 to the negative 11. Does everybody see that? Because what I'm looking for, once again, is do I have one number in front of my decimal? So once I get here, I know I'm getting close, so I slow down and go, okay, 3, 6, 9, 10, 11. Okay? But now I need to go into engineering notation, which means what? Got to be a power of 3, right? So in this case, I get 43.6 times 10 to the negative 12. Okay? Everybody understand how we got there? So 43.6 times 10 to the negative 12. So what would my numeric prefix be for this one? 43.6 tera. And that is the notation for seconds. So 43.6 teraseconds. I'm sorry, not teraseconds, picoseconds. So that is 43.6 picoseconds. All right. All right. So looking at these, table 4. Now this one's actually kind of interesting because this is something y'all got to remember, first of all. What is multiplied? Whenever we're dealing with powers of 10, if I'm multiplying my exponents, what am I doing to my exponents? You're adding. So what you kind of need to do for each of these is every time you see multiplied, you just go in and put a plus sign. So if multiply is add, what is divide? Means subtract, right? Now then, does anybody remember the most basic of mathematic rules? You cannot subtract a what? What can you not subtract? Ever. Hard to pass.
Negative.
Thank you. Somebody came across and said negative, and that is correct. You never subtract a negative. What do you do instead? You add a positive.
You flip the sign.
Flip the signs. So, looking at this, we have milli multiplied or added to milli. What is milli? Okay.
Million.
Not quite. So y'all should all have your lab up in front of you. You have milli, micro, nano, pico, -3, -6, -9, and -12. Milli is -3. So you are essentially saying -3 plus -3. What does that give you? -6.
-6.
That should give you micro. Okay? That should give you micro. All right? So to do a different one, what about micro minus nano? And what do you need to be careful of doing here? Micro is -6, nano is -9. What do you not subtract? You cannot subtract a negative. -6 minus -9 should become plus a +9, which would give you not -3, should give you 3 or kilo. Does that make sense? You cannot subtract a negative. It is forbidden. Don't do it. I don't know how many times I have to say it. Math teachers everywhere would go up in total screaming fits if y'all did that in their class. Don't do it in mine, please. I get so many people that subtract a negative, and I'm always one person going, no, you can't do that. Why? Because that's a rule. You don't subtract the negative. You add the positive. Okay? You don't subtract the negative, you add the positive. That's what you need to do with that particular set of problems. These right here are just translation. And then we come down to these. These are fun. These are lots and lots of fun. Okay? We'll do some of the basic ones in a minute. I want to do the really nice long one, because I know that is the biggest, most challenging one that y'all will face. All right, and for those of y'all playing at home, I'm going to switch y'all over to a whiteboard. I wish I could. All right. We're going to do this instead. Control C. Control V. Okay. So looking at this is going to be the fun thing. All right. So how many of you remember how to solve something like this? Because believe it or not, this is not solved the way you're thinking it is. Because this is actually solved from left to right. The very first step, don't know why I'm trying to do it that way. It's much easier to do it this way. This would be your first step. Okay? All right, so we have 28 times 10 to the 9th times 3.5 times 10 to the 3rd. So we're multiplying, first of all. What does that mean we do to our exponents? Means we're going to add our exponents after we multiply our whole numbers. So what is 28 times 3.5? That's what now? 98? All right, so we have 28 times 3.5 equals 98. So what is 10 to the 9th plus 10 to the 3rd? 10 to the 12th. Yeah, I'm not sure how to do exponents with this right now. Let's just do it this way. So 98 times 10 to the 12th. All right. Next thing I'm going to do is bring down part 2. Why is it doing this? There it goes. I give up. This thing's not working right for me. Okay. So 98 times 10 to the 12th divided by 8 times 10 to the negative 6. All right. All right, so what should I be doing here is I should divide 98 divided by 8, and then I should be doing 10 to the 12th should be subtracting 10 from, 10 to the 12th. I hate this thing. Will not let me do what I want to do right now. So 10 to the 12th minus 10 to the negative 6. What can you not subtract? Can't subtract a negative. All right? So what do you end up with? What is 98 divided by 8? It's what now? Times 10 to the what? Should be times 10 to the 18th, right? Why does it work sometimes it doesn't work others? All right, and then the last thing I've got to do is bring down and multiply the last section. So I have 12.25 times 4. And with that, I've got 10 to the 18th plus 10 to the 1, which would give us 10 to the 19, right? So what is 12.25 times 4? I got 49 times 10 the 19th. Is that scientific or engineering notation? It's neither. Why? Scientific notation, what should I have in front? How many numbers should be in front of my decimal? Should only be one. So if I was to do scientific notation for this, it should be what? It'd be 4.9 times 10. I'm just going to put 10 to the 20. If I was doing engineering notation, it should be 490 times 10 to the 18th. Does everybody see how I did all that? Anybody got any questions on it? It looks so deceptively hard, but it is not that hard. It's fairly easy. As long as you're not trying to type it into the computer for some reason. Any questions, guys? Y'all follow all right? Okay. All right, so all that being said, let's look at the worksheet that I have for y'all. For those of you at home, this is something you'll get when you come back to class. For those of y'all here tonight, consider this enforced study. Why? Because I have no idea how many times I've told people to print this out and use it for study material, should y'all be having difficulties with this particular concept set, and they never do. It is available on your Blackboard page. There should be a total of 6 of them going around currently. I've got the rest of them here. What I will require for homework purposes is that you do at least 5 of each problem type. Again, consider this enforced study. I'll go ahead and tell you now, I'm not going to require this back until before the final. And there's a reason for that. These questions will be coming back onto every test until the final. Because all tests are cumulative knowledge. That means that what you see on test 1 will be on test 2. What you see on test 1 and 2 will be on test 3. What you see on test 1, 2, and 3 will be on the final. Simple as that, guys. So consider this reinforcing study material. I'm not going to ask that y'all do everything on every page. I'm not that mean. What I am going to ask is that you take the time is that you go ahead and take the time to go to do at least 5 problems from each set of problems. Again, the whole reason for that is that it's just kind of a way to reinforce studying for all this. Because I can tell you till I'm blue in the face that, hey, if you're having problems with this, print this out. This is great study material. Guess what? How many of y'all will print this out? None. Most of y'all would never consider printing this out. So I've taken it upon myself to make this you must use this as study time material just to help you out. But I'm not the mean person that sits there and goes, you have to do every single problem in this. No, you cannot escape from having to do every single problem in this. Nah, it's kind of up to you to make sure you get it done. All right. Now, the main ones I would suggest y'all focus on is ones where you have to express in scientific notation and engineering notation. Okay. Working through metric prefixes is a great one. Being able to convert. Now, this one is one we'll come back to in a minute because I want to do a few of those with y'all. I'm not so much worried about adding and subtracting because the main thing we're going to be doing is these two right here. The multiply and divide. Yes. Huh? Bathroom is out the door and follow the hallway around. So this is the main stuff we're going to be doing after we get done with the mathematics basics. That is adding and multiplying and dividing with exponents. So I would really suggest doing a deep dive on this section right here. Okay? I'm not so much worried about reciprocals and square roots. So I would definitely focus on doing the multiply and divide and then conversions. Okay? Those are the best ones I can sit there and go and point to and say, hey, use those, because that's the stuff we're going to be doing. Questions on any of that real quick? Or I give y'all, I'm going to go ahead and give y'all about a 10, 15-minute break, and then we'll come back and work a few. Sound good? And looking at a few of these problems right here, and using this particular metric conversion chart. And it also goes back to the when in doubt, write it out theory that I've got. Why? Because this actually does pertain to what you will be doing later. Okay? Now, I'm not so much worried about whether it's amps or ohms or hertz or whatever. What is the main symbol I'm going to be worried about for each one of these? The main symbols I'm going to be worried about are things like milli to micro or mega and kilo. Those are the letters I'm worried about here. Why? Because they have what? They have meaning. They have meaning. They have a meaning of how many times did you move this? Right? What did you do to get here? This has meaning. Okay? It exists for a reason. How about that? Does that make sense to everybody? All right, let me try something real quick. And we'll see if I can't move this to something that I can work with a little easier. There we go. All right, so the ones I'm mainly worried about aren't the second ones that you come up with. They're the first ones. So again, looking at milli and micro, kilo, mega, right? Nano, pico. These are telling me how many times I moved that decimal. They have a meaning. You cannot go without them. Why do you think I'm emphasizing it? Because you can't go without them. Because you would not believe how many people I give a test to that sit there and go, oh, well, I don't need the micro or the mega in this problem. They don't mean anything. Yes, they do. They mean a lot. So this goes back to when in doubt, write it out. Why? Because it makes things easier. So let's look at this one right. Let's give us some space. So number 14, I have 150 microhenry, and I'm looking to go to millihenry. I'm not really concerned about the big H right there. It means something that we're not going to get into right now. We're worried about the milli and the micro. So if we do the when in doubt, write it out, to get my decimal right here at 150 micro, okay? Micro means I moved my decimal how many times? Moved it 6. Okay? So 1, 2, 3, 4, 5, 6. I'm doing this with a mouse, so I'm sorry if it looks a little sloppy. So 0.00150. Okay? This is the when in doubt, write it out method, guys, because why? It makes it visually easier to see. Okay? So I'm moving from micro to milli. That means that I'm just going to put my decimal at the third placeholder, the -3. So my answer should be 0.15. Everybody see how I did that? Since I'm moving from 6 to 3, so if you look on your metric conversion table here, and you were to write this, you would have started off in this column right here. You moved back to this column right here. Does that make sense? So instead of moving the decimal 6 times to get micro, I only moved it 3 to get milli. Does that make sense? This is where you have to really start learning to get comfortable with that moving decimal. I wrote it out. I wrote it from my micro version, which is the 150 micro, I wrote it out. It goes back to that when in doubt, write it out. There's a reason I keep saying that. I want you all comfortable with taking numbers like 150 micro and being able to write it out into decimal format. Why? Because once you understand the decimal format versus the engineering notation, it makes it a lot easier to move between. Does that make sense? I'm not trying to overcomplicate, guys. I'm trying to figure out how to say this in a way that'll make it easy for y'all to remember. So let's take 1600, or I'm sorry, 16. So what that is 2,200 kilo. What that actually is, and once you become practiced at this, this becomes a lot easier, guys, I promise. So 2,200 in decimal form would be 2200, and then I've got kilo. Kilo has meaning. What does it mean? It means thousand. It means I've got 3 zeros after these. Okay? And I'm wanting to move from kilo to mega. All right, well, this is my kilo decimal place. Where's my mega? Means I would move it forward one more place, right? To be 2.2 mega. Okay. So you have 2,000, so you go from 2,200 kilo to 2.2 mega. The reason I'm getting y'all to do this way is because I can look at that number and go ahead and tell you 2.2 kilo, I'm sorry, 2,200 kilo is 2.2 mega. Why? Because I've done this for so long. I'm very comfortable with the decimal moving and being able to create better numbers. I want y'all to be comfortable doing the same. Does that make sense? So when in doubt, just go ahead and write it up. That way you have the ability to move that decimal wherever you want to. You become comfortable with moving that decimal wherever you need to. because it translates much more easily. Does that make sense? I can guarantee you, if you do the write it out method for a little while, soon you won't need to. Why? This will become child's play. You'll have it down really quickly. So looking at, you want me to do number 15? Okay. So 2,500 nano to micro. Okay. Let me see if I can erase some of this. Okay. Give myself some space here. Okay. So looking at number 15, I have 2,500 nano. So the very first thing I'm going to do is write it out. I'm going to start off by putting my 0, 0, 5, 2. To get to nano, how many times did I move that decimal? I moved it 9. I moved that decimal 9 times. So I've got 3 there. I'm going to put commas in it just to help visually break it up for me. I know I need another 2 to make 6. Another comma. And then I need another 3. Before I've got my decimal right here at the beginning, right? Do y'all see how I did that? Did I pull a magic trick? So what you started out with was 2,500 nano. Nano is 10 to the negative 9. That means I moved my decimal 9 times in that direction. Right? To get that number, I moved my decimal 9 times in this direction. Yeah? So to write it out, to move it back into full decimal notation, I move my decimal back to its original place. Since I know that I moved it 9 times to get the decimal here, I've got to move it 9 times to get it back here. Does that make sense? Yes. That's something you got to be very careful of. And that is technically a comma because you would not write a decimal as 2.500. I start counting from where the decimal should be at the very end. No. This number right here, 2,500. I just brought it straight up here. 2,500. Okay? Following me? Then I just traced the number back to its decimal. Okay? So essentially I took this metric conversion chart. And I said, I know I'm starting with my decimal here at the end of nano, right here. Right? My decimal point starts right here. So then I just trace it back to where my decimal ends, right here between the whole number and the first set of 3. Does that make sense? So I've got 9 places I've got to move that decimal. That means I've got 9 places I've got to fill out. Most of it's going to be zeros. Why? Because otherwise it would not have been that long number. Okay? start off with the number I'm given, and I moved it back into decimal notation. So my decimal notation is where I just started out before I start solving. From here, I can sit there and say, I'm going to micro. Okay, so that means I'm going to have to count out for 6 decimal movements. Why 6? Because micro is 10 to the negative 6. Yeah? So there's negative 3 milli. There's negative 6 micro. That's why I put the commas in there. So your answer should be 2.5 micro. Does that make sense? So all I did was take it from the format I was given. I wrote it out into its full. I went back 6. All I'm doing is taking the number I'm given and putting it into its original decimal format. The only reason I write it out like this is so that it's easier for y'all to start tracking and tracing these numbers. So number 17. So we're starting at 5.6 mega and we're moving down to kilo. No, kilo's a positive 3. So what I would start off by doing is 5, 6. All right, so mega is 10 to the 6th. So that means I'm going to have to move my decimal place from between the 5 and the 6, moving it by power of 3. There's 3. There's the other 3. So this right here for kilo, 5,600. Why? Because I've moved from mega, which is where this comma is. I moved it down to kilo, where this comma is. Okay? 5,600 kilo. The decimal is going to come after the first. All right, let me put it this way. You're going to follow the comma. Think money or any of the other big numbers you're used to dealing with, right? What do we do every what do we do after every 3 numbers? We put that comma in, right? You know what I'm talking about? So it's going to follow the commas. So kilo goes to that first comma space. Do you know what you see what I'm saying? Kilo is going to go here to the first comma. Mega would go here to the second one. It follows that comma religiously. Okay? If I was to do giga, which is the power of 9, my comma would be right here, 3 more spaces after that 5, or 2 more spaces in front of that 5, because it's following the comma. The same thing for the negatives, only the negatives you have to put your own comma in. Okay? And that's the reason why I've got the commas in there, is because it visually breaks it. Does that make sense? Does it make a little more sense now? So for something, let's say, it'd be, I'm trying to do this with a mouse and it's not working out for me. 5,600. And I'm trying to do this with a mouse, not the best. It's exactly what you're doing is, okay, let me see if I can say this in a different way. What you're doing with any of this, and the whole reason I'm saying write it out is because I want y'all comfortable with moving this decimal. Always assume one of two things. If you do not see the decimal placed, such as right here where it says 0.22, assume that the decimal is at the end of your number. Okay? Why? Because that's normally where we would have a decimal. If we don't put a decimal, we assume the decimal is where? The very end. Why? Because that's the way we have been taught to think of math. Yes? So something like this guy right here, 17, that's 5.6. Why do I know that's 5.6? Decimals between 5 and the 6. Okay? So knowing that, when I go to write it out, I know that decimal is going to have to turn into a comma. Why? Because it's 5.6 mega, and I'm trying to bring it down to kilo. So when I go to write it out, I'm going to start off by writing my 5 and my 6, and I'm going to put that comma in between. Then I'm going to look at my chart and say, I'm going from mega, which is how many spaces have I moved that decimal forward? I've moved it 6 spaces forward to get that decimal between my 5 and my 6. Does that make sense so far? Is everybody following so far? In order to get it there, I've moved my decimal point 6 times to get it here. So in order to write it out into its full decimal format, how many times do I have to move the decimal the other way? 6. That 6 will include the number 6. Why? Because I moved it in front of the 6. I now have to move it behind the 6. Does that make sense?
So basically, like, decimal, instead of going behind the one I go before.
My understood decimal should be this place right here, yes? That is where I always want my decimal to come back to, which no matter which way I'm going. Okay? This is where my decimal originates from. All right? You'll see that? Okay. I know I have 3 spaces per section. Why? Because that's where our comma would run. Okay. So let's look at, all right, let's look at number number 6, I have 1.3 megahertz. And it's telling me I need to move it down to kilohertz. Okay? So I'd start off, first of all, taking my number 1.13 mega. Here's my mega. I have 1.13. Okay? 1.13 mega. Y'all see where I've started out? So in order to put it to decimal, I'm going to have to fill everything else in with zeros. Why? Because there's no other numbers behind it. So we assume it's 0. Okay? To move it to kilo, here's mega, here's kilo. My decimal is going to move to right here. So for number 6, it should read as like that. Yeah. Go ahead. Come on. Frank's over there. You want to erase something?
I thought we erased it.
Yeah, we don't have that. We've got that. Number 18. So you're starting off at 1,000 micro.
I started off. My one will be here or here.
It will be here.
Right?
Yep.
It's my decimal, right? Good. And now I'm gonna go from this to this, right?
Yes.
So that means I gotta go.
First of all, you need to take it from your decimal format. So that's 1,000 micro. And you're bringing it back to milli.
This one.
Mm-hmm.
So I gotta go from here, right?
Mm-hmm. So initially your decimal was right here. You moved it 6 places to get here. So that's moving it back 3. Then moving it back 6 would bring it back to basic decimal. You only need 2 zeros, not 3.
Now why would I only need?
Because you've already got one number as a point there.
I already got this number.
You've already got that number as one number in there.
And since this is a negative, we going back, right? So that means I go 1, 2, then 3. So would it be this right here?
Would be 1 milliamp. Yep.
So once you take the decimal from it, well basically behind it, since once you take it from behind it, you don't look at the zeros no more behind it.
You don't need them anymore.
Hold on, I need one more. Cause I have a hard time and I get irritated, frustrated when I don't know what I'm doing.
That's fine. I don't mind somebody coming up here and looking at and playing on the board.
25. That's a 1.
He's talking about this one right here.
I know what you're talking about. I'm trying to see. What that means. So my 1 would be right.
It'd be at the very, very end of your scale. So it would be literally 12.
It wouldn't be right there.
1 pico would be here.
And then I go back 12.
So you had to move the decimal 12 places to get that 1 in front of it.
And I only need 2 zeros right here, right?
Mm-hmm. And you're back to decimal.
And then I go 9.
Mm-hmm.
This way, right? So that.
Mm-hmm.
I start from right here.
Nope.
Right there.
Right there.
So with that be
0.001.
yeah. Okay.
Yep.
Yes, sir. Okay. I got it. Pretty much. 18 is the same. That's the same. That's the same answer.
I thought we need one more. I'm gonna let you
Well,
get
how
it.
come
One
for
more.
18 it says 1.000? It should have just said 1, right? Am I tripping?
For 18, that's 1,000.
Oh, so it's
Yeah, whenever they, I'll go ahead and confess something. Nancy Wilson copied this over from a book a long time ago, and it was a copy of a copy. That's why it looks like it does. Okay? That's why some things are a little clearer than others. I can't really change anything about it. I don't even know what book it came out of.
Did I do it wrong?
All right. In this case, yes, because what you're starting out with is 4,700 kilos.
So I had to
So
start
you're
there.
starting out in kilo first.
I did.
So the last decimal right here, decimal is supposed to be here. So it ends, the decimal ends on kilo. So it ends, the decimal is here.
So I will start from here.
Yes. That make sense?
Yeah. I thought I had it right. I was
You're
almost
close.
there.
This is what I encourage a lot of practice with this.
Okay. Now, around.
Close, but not quite.
I need to come up with one more.
Yep. So it should be 47,000 kilos. Okay?
No. We're
Going to giga.
so we're going that way.
That way. Big G.
Oh yeah, you're right. And does it matter when you start it in given? You get what I'm saying? Like, do I supposed to start right here?
Okay,
Or is
so
that
this
rhetorical?
one's an interesting one if you don't want to start back here at 0. because this is what the number actually is as its decimal form. Okay? What you're trying to do is bring your decimal here.
So that means
So it would be 0.047 giga.
and then this would be like I'm gonna add 7.
I'm gonna definitely have to do what he doing to understand this.
What now?
I said I'm gonna definitely have to do what he doing to get this all the way.
Yeah, because
Well, that's why
I had to come up here, bro. I had to see because I was like, what?
this is why I gave y'all this whole packet to play with, because this is a concept. This is the beginning of learning a totally different language and way of thinking. Truly it is. Because metric is in and of itself its own language. And it's one most of the
Yeah, because I can't learn this in here.
Eventually,
Yeah, so I definitely got to do that. Definitely got to come up there and do the board stuff.
yep. Well,
So with this one, I would start right here.
yes.
So when you do it, could you like speak a little louder?
So he's starting off at 22 milli,
And then I'm going that way, right?
and he's working to micro.
So that's 6.
Mm-hmm. There's a 0 in front of the 2, because that would be the proper decimal format, would be 0.022.
Because it's no decimal? Or is it just
Because
there's a 0 right here?
because there's a 0 right there.
So now I will start from in between the 0 and the 2. I'll start behind the 0.
Mm-hmm.
So
So whenever you move it to the 6th place,
that'll make it 22,000.
yes.
Like that, right?
Yes.
I think I might got it. I just gotta keep practicing. I'm learning. I'll let you have it. And I'll be one of you all.
So does micro go to the right, mega means go to the left? Or did I not hear that right?
So micro, you would go to the right.
It's basically like if you can see like alright, we're gonna say like the one I was just doing, right? It started with the little M. You get what I'm at? So what that mean is you gotta go to the U. So,
I'm not gonna hold you, bro. I cannot see that.
oh, I'm sorry. I'm sorry. Can you see better?
All right, thank you. Thank you very much.
Yeah.
Yeah, I see it.
All right. Now you see how we went from this letter and we went to that letter. You just don't follow the letters, whichever way. Like, all right, say if we was going from the little M to the big G, then that means you'll have to go backwards. You get me?
But you would section it off like how you got it right there when you trying to go over there.
Talking about like this. If that helps you
Yeah.
make it
You see how?
on the board,
Go ahead. Go ahead. Go ahead. Go ahead.
yeah, you said like yeah, you see how it's on the board, like you see how we started from right here, but by the number being positive of whatever letter you got at the very top, right here, whatever letter you got at the very top is how many numbers you gonna go forward or backwards with your numbers at the bottom. You get what I'm saying? Does it make sense?
Okay. Okay. I feel you. I feel you. I
So,
need that paper for sure.
yeah, yeah, most definitely.
I appreciate that, man. Thank you.
Ain't no problem.
I will say this, guys. I'm here all day, or not all day, but I'm here from 12 until class every Tuesday and Thursday. So if y'all want to come in for extra time and help, you're more than welcome to.
Oh, you said you had, I was about to say, y'all come in and help.
I'm here to help. I'm here to help you. How about that?
Oh, you know, you're
Okay. That's kind of why I wanted y'all to practice with this and kind of get the idea of why I tell y'all, when in doubt, write it out. I know it sounds so silly, especially when working with this, but whenever you start digging into all this, it can become less confusing if you're used to just going, oh, I've got to move my decimal this way, that way, and another way. Because a lot of the numbers we're going to be dealing with aren't going to come in decimal format. A lot of the numbers we're going to work with are going to be things like 22 kiloohms. And you need to know 22 kiloohms. Oh, that's 22,000. Or we might be working with 32 microamps. You need to know that's 32 times 10 to the negative 6. That's kind of why I was getting y'all into some of this, is because this letter right here doesn't matter right now. The main one you need to worry about are these, and getting those memorized and known. Because whenever we get into actually working with electricity, these are the main things that you work with. You're not going to be working with decimal format numbers. We're not going to tie it up like this. That's too many zeros, right? We're going to be tying it up into smaller and smaller packages. Why? Because it makes it neater. It makes it easier to understand. This is the written out version, and what you need to do with these, there's 3 sections of this in this packet, guys. I'll tell you that now. One is doing metric prefixes, one is doing engineering notation, and one is doing scientific notation. They're pretty much, no, I won't say that. There's 2 sections to the test. One paper portion where, yes, you're going to have to show a little work. I'm not going to ask you for all the work, but you're going to have to do some work. I want to know kind of how you got where you got. I'm not going to expect you to show me every last little step, but I'm going to expect you to say, okay, so I understand that this is, I have to divide 1/2 by 3/4. This is how I've got to do this. Okay, I'm not expecting 20 million steps, but I'm not expecting no steps either. Put it this way. If you get it wrong and you show me work, I give you half credit. Okay? How about that? You get the answer wrong, but you show me work, you get half credit. I try to be nice whenever I give y'all paper portions. The online portion is strictly multiple choice. I can't give you half credit for multiple choice. Right? Can't do it. I can't sit there and look in your brain and go, this is what they meant, this is what they did. No, I can't do it. I don't have that power.
So how would you write that?
Do you want me to do it as the metric prefix, the scientific, or the engineering notation? This particular one is asking for metric prefix. In this case, this would be 39 kiloohms. Kilo. Kilo.
So how you know when to go from to what?
because you're starting out with your decimal right where it's supposed to be. Does that make sense? Your decimal starts out where it's supposed to be, right here. Then you're just moving it to wherever you've got to move it. Does that make sense? It's kind of why I want y'all to work them back and forth so that you're comfortable having that decimal move on you. I'm going to eventually have to go in and actually rewrite all these and make them into a table. That's going to be a pain. But I'll eventually have to do it. So if I was to write this as 12 ohms, because it's a whole number. Whole numbers have no notation. Because you're moving by powers of 3, since it's in the whole number section of that, there is no notation.
Okay, so what about
24, that would be 390 milliamps. Because your decimals here, you have this as a 0, and that is 3 and a 9. So you'd have to move the decimal. So you have 0.39, which I'm very bad about not putting the 0 in front of a decimal. I've never had the inclination to generally do that for some reason. So you have to move it in sections of 3. So 1, 2, 3. I know that there's a 0 back there because this goes back to thinking like an old calculator. If you ever remember the old calculators, you had your decimal there, you might have a 7653 or 87653. And then at the very end of that calculator, just as placeholders, doesn't mean anything, you would have zeros. Just hanging out, doing what they do.
So
Waiting for something to come and use it. 150. Yes. So think of it like any of these numbers, think of it like this. You've got zeros out there that you can use at any point in time. You just have to use them. Where does what now? It's a shorter way of writing it so that you can convey big numbers in a smaller term. Does that make sense? Well, think about it as a memory drive, a flash drive. Okay? How do you know what's a better memory? What holds more? We know by the term, right? So when it first all came out, what did it come out as? It started out as kilobytes, right?
for me, it just started turning into like gigabytes until it got to like PlayStation 3 and PlayStation 4.
Mm-hmm.
When they brought out PlayStation
It started out, memory was in kilobytes, right?
Yeah.
It was very, very, these days you consider it very, very primitive memory.
Well, we still had gigabytes on this.
Yes, you could get memory cards, but they were expensive, and then those have become giga. Just like today, you can still go get megabyte memory sticks. You know, they say MB. Well, you know that that's not a very big memory, but it's bigger than a kilobyte, right? But it's less than a gigabyte. These days, they sell memory storage in what? What's the biggest one they sell? Terabyte. What is a terabyte? Well, they sell, it's a lot of memory, right? Means it holds a lot of data storage. That's all any of this is it's just small terms to convey big or small numbers without having to write out the million and one zeros. Does that make sense? Kind of like, how do they tell you what a billionaire is worth? They sit there and they say, well, who's a good billionaire? You've got, Tyler Perry? I don't know what he's worth. I was thinking more of Bill Gates or somebody. You're talking lots and lots of money. They've got billions of dollars that they've got. Do you know down to the penny? No, they rounded off in the billions, right? Well, same thing you're doing here with these numbers. You're not wanting down to the last little digit. You're wanting to shorten it up so that you can convey that information in a quicker way. Does that make sense? Well, that's why I gave y'all that lab, and that is why I've given y'all this worksheet. It's lots and lots of good practice. So, I'll tell you what. I'm going to pause out recording for right now.